Imagine you accelerate, faster than a jet, faster than a bullet, faster than anything humanity has ever built. The earth blurs beneath you. Cities smear into streaks of color. The atmosphere ignites around your body. The moon snaps past like a coin flicked into darkness. You keep accelerating. 10,000 kilometers per second. 100,000. The stars ahead begin to crowd together. The sky is no longer scattered with points of light. It compresses into a glowing tunnel, and then you approach the ultimate boundary, the speed of light. You've been told it's just a number. 299,792,458 meters per second, a cosmic speed limit. But that number hides something terrifying, because at the speed of light, something strange happens. Time stops, distance collapses, and seeing, the very act of perception, becomes impossible. So what would you actually experience if you could travel at light speed? Would the universe stretch into infinity? Would it freeze? Would it explode into color? Or would it vanish completely? The truth is stranger than all of those, and to understand it, we have to break reality itself. The moment you pass 1% of light speed, the world begins to change. Not visually at first, not in the cinematic way movies show it. There's no sudden warp tunnel, no sci-fi shimmer. Instead, reality begins to tilt. In 1905, a patent clerk named Albert Einstein published a paper that quietly rewrote the rules of existence. Special relativity. Two simple ideas. The laws of physics are the same for everyone moving at constant speed, and the speed of light is the same for everyone, no matter how fast they're moving. That second statement is the crack in reality. Because if light always moves at the same speed relative to you, no matter how fast you go, then something else must adjust, and that something is space and time themselves. As you accelerate toward light speed, clocks around you begin to tick differently, not metaphorically, physically. A second for you is no longer a second for someone standing still on Earth. Time slows down. This is called time dilation, and it's not theory, it's been measured. Atomic clocks flown in airplanes return slightly younger than identical clocks left on the ground. But that's only the beginning. As your speed increases, lengths in the direction of motion contract. The distance between you and a star ahead shrinks. Space compresses like an accordion squeezed from both ends. From your perspective, the universe ahead becomes thinner, and the faster you go, the more extreme it gets. At 90% of light speed, the distortion becomes dramatic. The stars no longer appear evenly scattered. Light from the front of your direction compresses into a bright cone. Behind you, the universe dims and reddens. This is relativistic aberration. Imagine raindrops falling straight down while you stand still. They hit your head vertically. But if you start running forward, the raindrops seem to slant toward your face. Now replace raindrops with photons and running with near light speed. The entire sky shifts forward. Stars migrate toward the center of your view. Constellations distort. Familiar shapes dissolve, and the light itself changes color. This is Doppler shift, but magnified beyond anything you've experienced with sound. Light waves in front of you compress, shifting toward blue and eventually beyond visible light into ultraviolet X-rays, gamma rays. Behind you, light stretches into red, infrared, radio waves. The visible universe narrows. Ahead, blinding blue-white intensity. Behind, darkness. You are not just moving through space. You are moving through reality's fabric. At 99% of light speed, something deeply unsettling occurs. Time dilation becomes enormous. For every second you experience, many seconds pass on Earth. At 999%, years could pass for them while you feel only moments. From your perspective, distances shrink dramatically. The nearest stars seem closer. The galaxy compresses along your path of motion. You could, in principle, cross the Milky Way within your lifetime because the galaxy contracts in your direction. But for everyone else, tens of thousands of years would pass. Already, the concept of what you see is fracturing, because what you see depends on how space and time bend around you. Now push further. Imagine somehow reaching 9,999,999% of light speed. The light from directly ahead becomes so compressed that visible wavelengths shift beyond human perception. Gamma radiation floods your forward vision. Deadly, invisible, intense. If you had eyes capable of seeing it, the universe would collapse into a brilliant, concentrated disk in front of you, a cosmic spotlight. Everything else would fade. Behind you, the universe would stretch and cool into blackness. The sky would no longer surround you. It would form a tunnel, a bright, shrinking, blinding tunnel. But here's the paradox. No matter how close you get to light speed, you can never reach it, because as you accelerate, your energy doesn't just increase normally. It increases relativistically. The closer you get to light speed, the more energy you need for even a tiny additional increase in velocity. At light speed, the required energy becomes infinite. Your mass, from the perspective of an outside observer, increases without bound. So to actually reach the speed of light, you would need infinite energy, and the universe does not allow that. But let's commit the ultimate act of imagination. Let's break the rule. Let's say you somehow become a photon. You are no longer matter, you are light itself. What do you see? The answer is deeply uncomfortable. Because from the perspective of light, time does not pass. According to relativity, as you approach light speed, time slows. At light speed, time dilation becomes total. The passage of time reduces to zero. That means a photon emitted from a star millions of light years away does not experience travel. From its own perspective, if such a perspective existed, emission and absorption are the same event. It leaves a star. It arrives in your eye. Instantly, distance collapses. The entire journey across the universe becomes a single timeless event. So what would you see at the speed of light? Nothing, because seeing requires time. Seeing requires change, a sequence of moments. Photons hitting your retina, neurons firing, signals traveling. At light speed, there is no after to process what just happened. There is no frame, no motion, no experience. The concept of observation dissolves. The universe becomes a frozen, zero-duration bridge between 2 points. This is the first shock, but it's not the deepest one, because when we push further, when we explore how space-time geometry behaves at that limit, something even stranger emerges. If time collapses for light, and distance contracts infinitely in the direction of motion, then the path of a photon through space-time has zero length. In a sense, every photon connects its origin and destination directly, across billions of light years, without time, without distance. The universe, from light's perspective, is not vast. It is compressed into contact, which means the cosmic scale we perceive, galaxies separated by unimaginable distances, may not be fundamental at all. It may be an artifact of moving slower than light. What if the structure of reality depends on speed? What if the vast emptiness of space only exists because we are too slow? Now we begin to confront something radical, because if you could somehow perceive at light speed, the entire observable universe would collapse into a two-dimensional boundary ahead of you. All events along your direction of motion would compress into a single surface. Space would lose depth, time would lose flow, causality would strain, and the idea of before and after would blur into a single, eternal now. But here's the twist that changes everything. Even though nothing with mass can reach light speed, we are constantly interacting with things that do. Every time you open your eyes, you are receiving ancient photons. Light from the sun left 8 minutes ago. Light from distant galaxies left millions or billions of years ago. And when those photons reach you, for them, no time has passed. The Big Bang and your retina are separated by zero experienced time, from the photon's point of view, which means every act of seeing is a direct connection across cosmic history. You are touching the ancient universe without delay, from its perspective. And that reframes the question entirely. Maybe the real mystery isn't what you would see at light speed. Maybe it's what light sees of us. Because every photon that leaves your face, every reflection, every glimmer, travels outward at light speed. To distant stars, to future civilizations, to the edge of the observable cosmos. For that photon, its departure from you and its eventual absorption, perhaps billions of years from now, are the same moment. Your present is welded to some distant future point in space-time, instantly, which means the universe is stitched together by timeless threads of light. And we live in the slow, stretched-out version of that deeper structure. So what would you see at the speed of light? You would see the collapse of space, the freezing of time, the end of perspective. You would see that seeing itself is a luxury of slowness. And yet, in a way, you are already participating in that boundary, every time you look at the sky. Because the photons entering your eyes are the universe arriving, without delay, from their own timeless journey. The speed of light is not just a limit, it is the edge where experience dissolves, and standing just below it, we glimpse something extraordinary. Reality is not fixed. It stretches, it bends, it depends on how fast you move. And if the structure of space and time changes with velocity, what else about existence is relative? That is where the next layer begins. Because when we go beyond special relativity, when gravity enters the story, the meaning of light speed becomes even more unsettling, and the universe reveals a deeper secret hiding behind its brightest constant. You have reached the edge where velocity alone warps reality. Now gravity enters. And gravity does not gently bend the rules, it curves the stage on which the rules exist. When Albert Einstein expanded his 1905 ideas into general relativity in 1915, he made a claim so audacious it still feels dangerous. Gravity is not a force pulling objects together. It is the curvature of space-time itself. Mass tells space how to curve. Curved space tells matter how to move. And light, even though it has no mass, must follow those curves. Which means light does not travel in straight lines. It travels along the geometry of reality. Imagine you are accelerating toward light speed near a massive object, a neutron star perhaps, or something far more extreme, a black hole. Near such an object, space is not flat. It dips, it folds, it deepens into a gravitational well so steep that even light struggles to climb out. From far away, light always moves at 299,792,458 meters per second. That constant remains sacred. But near intense gravity, something else shifts. Time itself slows down relative to distant observers, not because you are moving fast, but because gravity warps the flow of time. Clocks deeper in a gravitational field tick slower. This is gravitational time dilation, and it's been measured. Satellites in orbit tick slightly faster than clocks on Earth's surface. The GPS system must correct for it continuously or it would fail within minutes. You are already living in curved time. Now imagine approaching a black hole while traveling at a significant fraction of light speed. Two distortions begin to compound. Your velocity dilates time. Gravity dilates time. Space contracts in your direction. Space curves around mass. The universe becomes an unstable lens. Ahead of you, light from distant stars doesn't simply compress into a cone. It bends around the black hole's gravity. You begin to see stars behind it, warped into arcs. This is gravitational lensing, mass acting as a cosmic magnifying glass. Light from objects hidden behind the black hole curves around it, forming rings and crescents, what physicists call Einstein rings. The sky fractures into halos. At extreme proximity, something even stranger happens. There exists a boundary around a black hole called the event horizon, the point of no return. Cross it and escape becomes impossible, not because you are pulled inward by force, but because all possible paths through space-time curve inward. Even light cannot find a trajectory outward. Now imagine you approach that boundary at near light speed. From the perspective of a distant observer, you appear to slow down as you near the horizon. Your clock ticks slower. Your image reddens and dims. You never quite cross it, at least, not in their time. But from your perspective, you cross in finite time, and the light around you behaves like something alive. Photons orbit the black hole in unstable paths. There exists a photon sphere, a region where light can circle the black hole in loops. If you were there traveling near light speed, you would see something profoundly disorienting. You could look forward and see the back of your own head. Because light emitted from behind you could orbit the black hole and return to your eyes. The universe would fold around you. Up would lose meaning, forward would bend, behind would curve into view. The concept of a stable visual field would dissolve, and as you accelerate even closer to light speed near this boundary, the distortions amplify. The entire external universe compresses into a shrinking patch above you. The rest of your visual field becomes the black hole's darkness. Not empty, but dense with warped light spiraling inward. Time dilation now becomes extreme. For distant observers, entire civilizations could rise and fall while you experience minutes. If you hovered just above the event horizon at 999% of light speed, the outside universe would appear to accelerate wildly. Stars would burn out and fast forward, galaxies would shift, cosmic background radiation would blue shift into energetic fury. The future of the universe could unfold before your eyes. compressed into a brilliant torrent of radiation from ahead. Because as you approach light speed, the light from the universe's future, relative to you, shifts toward higher energies. The deeper you fall into gravity, the more the external universe speeds up relative to your slowed clock. There is a theoretical scenario where, if you could hover infinitesimally above the horizon, you might witness the entire remaining lifetime of the universe outside. Not because you move forward in time, but because time outside moves faster relative to you. The sky would brighten into a final blaze, then fade, then redshift into darkness as stars exhaust themselves. The universe would grow cold, all while you linger in slowed time. But this is where the paradox sharpens. Because no matter how extreme the distortions become, you never see light stand still. Light always moves at light speed relative to you. This constancy is not negotiable. Even if you chase a photon at 999,999%, it still outruns you at full speed. The universe rearranges its geometry to protect that invariant. Space contracts, time dilates, energy inflates. But the speed of light remains untouched. It is not just a speed, it is a structural property of reality, a conversion factor between space and time. When you push toward it, you are not merely going fast. You are rotating through space-time itself. In relativity, space and time are not separate dimensions but components of a unified fabric. Moving faster through space means moving slower through time. At rest, you travel entirely through time. At light speed, you would travel entirely through space. But here's the subtlety that changes everything. From the perspective of space-time geometry, light doesn't move through time at all. Its path through time is zero. It exists only along spatial direction. Which means the deeper truth is not that time stops at light speed. It's that time becomes perpendicular to your motion. The axes of existence tilt. Imagine a graph where vertical is time and horizontal is space. At rest, your path is mostly vertical. As you accelerate, your path tilts. At light speed, your path lies exactly along the boundary, the light cone. You no longer move upward through time, you move sideways through space-time. And that boundary, the light cone, defines causality itself. Events inside your light cone can affect you. Events outside cannot. Light speed separates cause from impossibility. So when you ask what you would see at light speed, you are really asking what happens at the boundary of causality, and the answer is unsettling. Because at that boundary, the distinction between here and there blurs, distance contracts to zero, time collapses, cause and effect merge into contact. Light emitted billions of years ago and absorbed today are not separated by duration along their own path. They are adjacent in space-time. The vast cosmic timeline we imagine is not fundamental for light. It is fundamental for us, because we move slower, which leads to a quiet but radical implication. The structure of reality depends on perspective. Not in a vague philosophical way, in a geometric one. Observers moving at different velocities carve different slices through space-time. They disagree on simultaneity, they disagree on duration, they disagree on length, but they all agree on one thing, the speed of light. It is the anchor point of reality. Now push further. Imagine not just a black hole but the early universe. Shortly after the Big Bang, the cosmos was a dense hot plasma where photons scattered constantly. Light could not travel freely. It was trapped in a fog of charged particles. Then about 380,000 years later, the universe cooled enough for atoms to form. Light decoupled from matter and began streaming freely. That ancient light still surrounds us today as the cosmic microwave background. When you look at it, you are seeing a baby universe. But for those photons, no time has passed. From their perspective, the birth of atoms and your observation are contiguous. You are in direct contact with the primordial universe through timeless messengers. Now consider this. If you could accelerate to near light speed toward that ancient radiation, it would blue shift dramatically. Microwaves would become visible light. Visible light would become X-rays. X-rays would become gamma radiation. The gentle afterglow of creation would transform into a lethal blaze ahead of you. The universe's oldest light would become its most dangerous. Speed changes not only perception but physical consequence. Energy increases with frequency, and frequency increases with motion toward the source. Approach light speed, and the quiet cosmos becomes violent. Cosmic rays, background photons, starlight, all intensify. At sufficiently high velocity, even the sparse hydrogen atoms in interstellar space would become catastrophic projectiles, striking with enormous relativistic energy. The universe would no longer feel empty, it would feel solid, because emptiness depends on slowness. At near light speeds, even vacuum becomes resistance. The faster you move, the more the universe pushes back, not through friction but through energy density, which reveals another hidden layer. The speed of light is not just a limit for objects, it is a limit for information. Nothing can carry information faster, no signal, no influence, no causal effect. If something could exceed light speed, causality could reverse, effects could precede causes, paradoxes would bloom. The universe protects its narrative structure by enforcing this limit, and that suggests something profound. Light speed is not arbitrary, it is woven into the logical consistency of reality. To cross it would not merely be fast, it would be to step outside the framework that keeps events ordered. So when we imagine reaching light speed, we are imagining stepping beyond causality itself, beyond before and after, beyond sequence. What would you see there? You would see the end of narrative, the end of change, the end of experience, because experience requires ordered events, and at light speed order collapses. Yet we are haunted by the boundary. Every particle of light we see lives on it. Photons ride the edge of causality constantly. They define the structure of what can affect us. We live inside a constantly expanding sphere defined by light's travel. Your observable universe is limited by how far light has traveled since the beginning of time. That horizon expands every second. And beyond it lies a region you cannot see, not because it isn't there, but because its light has not had time to reach you. Which means the universe you experience is shaped entirely by the speed of light. It is the architect of your cosmic horizon, and that horizon is not static, it grows. But there is a deeper mystery hiding beneath all this, because if the speed of light defines causality, defines perception, defines the structure of space-time, why that number? Why 299,792,458 meters per second? Why not faster? Why not slower? That constant is not derived from something deeper in current physics. It simply is. A fundamental property. A conversion between space and time embedded in the equations. And when you stare at it long enough, the question begins to shift. Maybe the speed of light is not a speed in the way we think. Maybe it is the rate at which the universe processes change. A cosmic clock speed. A bandwidth limit on reality. Which raises a final escalation. If reality has a maximum processing rate, if space and time adjust to preserve it, if causality depends on it, then perhaps what we call the speed of light is not about light at all. It is about the structure of existence. And in the next step, when we descend to the smallest scales, where quantum mechanics rules and space-time itself may not be continuous, the meaning of this limit becomes even more enigmatic, because at the Planck scale the fabric of reality may flicker, and the boundary we call light speed may not be a wall, but a clue that the universe is built from something deeper than space and time. And if that is true, then the question, what would we see at the speed of light, becomes far more radical. Because the ultimate answer may not be about vision. It may be about the code of reality itself. Now we go smaller, not faster, smaller. Because if the speed of light is a boundary written into space-time, the next question is unavoidable. What is space-time made of? We have treated it like a smooth fabric, a geometric continuum, a stage that bends and stretches. But what if that stage is not continuous at all? At scales far smaller than atoms, smaller than protons, smaller than quarks, there exists a threshold called the Planck length, around 10⁻35 meters. At that scale, our best theories fracture. General relativity and quantum mechanics, the two pillars of modern physics, stop agreeing. And right there, at that fracture point, the speed of light sits like a gatekeeper, because the Planck length, the Planck time, the Planck energy, all of them are built using one constant, the speed of light, not as a speed, as a structural ingredient. Planck time is the smallest meaningful unit of time we can define, about 10⁻43 seconds. It is the time light takes to travel one Planck length. In other words, the smallest possible distance is defined by how far light can move in the smallest possible time. That is not an accident. It suggests something unsettling. Light speed is not just how fast light travels. It may be the resolution limit of reality, like pixels in a screen, frames in a film, clock cycles in a processor. Now imagine pushing to the edge again, not just accelerating your body toward light speed, but asking what happens if the structure of space-time itself has a maximum refresh rate, if reality updates at discrete intervals, if between one Planck moment and the next, there is no in-between. At human scales, everything appears continuous, smooth motion, flowing time. But at extreme magnification, reality may jitter. Quantum fluctuations, virtual particles popping into and out of existence, fields vibrating with uncertainty, and throughout all of it, nothing transmits influence faster than light. Why? Because if information moved faster than this limit, the entire lattice of cause and effect could tear. Think of the universe as a vast network, every event connected by threads of causality. Light speed defines the maximum rate at which updates propagate across this network. If one node changes, that change cannot ripple outward faster than light. It's a universal synchronization constraint, which raises a radical possibility. Maybe the speed of light is not a property of light. Maybe it is the maximum speed of change, the fastest rate at which reality can rearrange itself. And if that's true, then asking what you would see at light speed becomes even stranger. Because to move at light speed would mean moving at the same rate as reality updates. You would not be progressing through moments. You would be riding the boundary between them. Now return to the photon. Earlier we said that from light's perspective, time does not pass. But here's the deeper twist. In relativity, there is technically no valid reference frame moving at light speed. The mathematics breaks down. You cannot define a rest frame for a photon. There is no photon perspective in the usual sense, which means when we say from the photon's perspective, we are already stretching language beyond what physics permits. And that's the real shock. At light speed, the concept of perspective itself dissolves. Perspective requires a frame requires time, and time does not behave normally at that boundary. So perhaps the reason you cannot reach light speed is not merely energetic, perhaps it's structural. To reach light speed would not just require infinite energy. It would require abandoning the possibility of having a frame of reference at all. No clock, no coordinate system, no self-contained experience. Identity, as we understand it, depends on the passage of time. Your thoughts unfold sequentially, your memories stack in order, your awareness is a process. At light speed, sequence collapses. There is no unfolding, no before thought and afterthought, no gap in which awareness could exist. Which means the ultimate answer to what you would see at light speed is this: you would not be, because you require time to persist. And at that boundary, persistence evaporates. Now let's widen the lens one final time. The observable universe has a horizon, a maximum distance from which light has had time to reach us since the Big Bang. Beyond that, space may continue infinitely, but we cannot see it. Not because it's hidden, because light has not had enough time. Our cosmic horizon is defined entirely by light speed. And here's the quiet paradox. The universe itself is expanding. Distant galaxies are receding from us. Some are receding so fast that the space between us expands faster than light. This does not violate relativity because it is space itself expanding, not objects moving through space locally faster than light. And yet, it creates a haunting consequence. There are regions of the universe whose light will never reach us, ever, not in a trillion years, not in infinite time. They are causally disconnected, not because they are too far in a static sense, but because the expansion outruns light's ability to bridge the gap. Which means the speed of light is not just a speed limit. It is a wall between realities, a partition dividing what can ever influence you from what cannot. Your entire experiential universe is carved out by that constant. Everything you have ever seen, felt, measured, exists inside your light cone. Outside it lies an unknowable beyond. Now imagine again accelerating toward light speed. As you approach it, your forward view compresses. The universe ahead blue shifts, intensifies, condenses. Behind you, darkness expands. Your light cone narrows. You become increasingly aligned with a single direction in space-time, until, at the limit, your light cone collapses onto a line. All possible futures squeeze into a boundary. All possible pasts compress into contact. The geometry of existence flattens. And here is the final conceptual shock. Light does not experience distance. Light does not experience duration. And yet light connects everything. It is the messenger between stars, between epochs, between minds. It defines what can cause what. It shapes the size of your universe. It stitches space-time into a coherent structure. And it does all of this while living on the boundary where time vanishes. So perhaps the most profound answer is not that you would see nothing at light speed. It's that light itself is the act of connection without experience. It is relationship without duration, a bridge that does not traverse. Now turn inward. Your brain operates through electrical signals, electromagnetic interactions limited by light speed. Your perception of the world is delayed by finite transmission times. Light hits your retina. Signals propagate through neurons. Chemical cascades unfold. Everything you experience is slightly in the past, by milliseconds, by minutes, by years when you look at distant stars. You have never experienced the present moment of the external universe, only light that has arrived from it. Your reality is a mosaic assembled from delayed photons, which means even at rest you are living inside a light-speed filtered version of existence. Now consider this. If the speed of light were slightly faster, the universe's structure would differ. Stars might burn differently. Fundamental constants would shift. Chemistry could change. If it were slower, causality cones would narrow. Structures might not form as they do. The value of light speed is woven into the stability of atoms, the behavior of fields, the architecture of cosmic evolution. It is not a superficial parameter. It is foundational, and we do not yet know why it has the value it does. It emerges in Maxwell's equations of electromagnetism, the equations that describe electric and magnetic fields. Long before relativity, those equations predicted a wave that moved at a specific speed. That speed turned out to be light, which suggests something subtle. Light does not define the limit. The structure of electromagnetic fields does. And relativity generalizes that structure to all interactions. The constant we call c is less about light beams and more about the symmetry of space-time itself. It is the invariant interval that all observers agree on. It is the conversion factor that ensures the laws of physics remain consistent no matter how you move. So when you ask what you would see at the speed of light, you are brushing against the symmetry of the universe, a symmetry so strict that it reshapes space and time to protect itself. And perhaps that symmetry hints at something deeper still. Some theories suggest space-time may emerge from entanglement, from quantum connections between microscopic degrees of freedom. In certain approaches to quantum gravity, geometry is not fundamental. Information is. And if geometry emerges from deeper informational relationships, then the speed of light might be the maximum rate at which information entanglement can reorganize. A fundamental bandwidth, the cosmic bit rate, we do not yet know, but we suspect the boundary is not arbitrary. Now return to the opening image, you accelerating, the sky collapsing into a brilliant tunnel, colors shifting beyond human perception, time outside racing forward while yours slows, the universe compressing into a radiant disk. And then, at the limit, silence, no flow, no frames, no experience, because experience requires slowness. Consciousness is a low-velocity phenomenon. It unfolds beneath the ultimate speed limit. Light lives at the boundary. We live below it. And perhaps that is not a limitation. Perhaps it is a gift. Because below light speed there is duration, there is sequence, there is story. Above it or at it, there is no narrative, only structure, only connection, only geometry without unfolding. So what would you see at the speed of light? You would see the end of seeing. You would see that vision depends on time, and time bends under motion. You would see that distance is not absolute, that simultaneity is negotiable, that causality has an edge. And then you would realize something even more unsettling. You are already riding through space-time at light speed, not through space, through space-time. Every object moves through the four-dimensional fabric at the invariant magnitude of c. When you are stationary in space, all of that motion is through time. As you move faster through space, you trade motion through time. The total remains constant. You are always moving at light speed through reality, just divided differently between space and time, which means the boundary you were chasing was never external. It was embedded in your existence. You are not separate from the speed of light. You are structured by it. And that final realization folds the paradox back on itself. You asked what you would see at light speed. The answer is nothing, and everything. Nothing, because perception cannot exist there. Everything, because light already connects every event within your causal horizon. You live in a universe defined by a constant that limits you, shapes you, protects causality for you. And standing just beneath that boundary, in the slow unfolding of moments, You are witnessing the only kind of reality that allows stories to exist. A reality stretched out below the speed of light, where time flows, where distance matters, where questions can be asked, and where, mercifully, they do not all collapse into a single timeless point.